Here's an integration technique that will elevate your skill set. Trig substitution is used for integrals in this form. Now, notice that they're all in the same form where you have an x squared added or subtracted to a constant a squared. In two examples, the values are underneath a root, and in the other, they're not. Now, to solve these integrals, we're going to go ahead and draw some triangles and use SOHCAHTOA so that we can rewrite this in a better form. Now, I'm not saying that we will get a nice solution at the end, since these integrals do turn into some trigonometric form, but at the end they are integrals that can ultimately be solved in such forms. Today, I'm simply going to show you how we change these trig substitutions using the right triangles, and we can discuss how to solve them in a later video. Okay, let's get started. Okay, so let's go ahead and talk about an integral that looks like this. As I mentioned, since we're going to use trig substitution, we're going to go ahead and draw a right triangle. I'm just going to label this so we know exactly that it is a right triangle. And now every single time that we have the constant first minus that variable, we're going to go ahead and label our triangle in this way. We have our theta, which is going to be the angle that we're focused on. We're going to make our opposite the x, and then we're going to make the hypotenuse the a value. Now, I'm just going to show the work here using Pythagorean theorem so you know how we're going to find that other side. So if you recall, we have x squared plus, let's label this b squared is equal to a squared. And so now if we subtract the x squared to the other side, we have almost exactly what we need, because b is equal to the root a squared minus x squared. And that is the adjacent side here. And so now what we can do is we can say sine theta is equal to x over a. In other words, a sine theta is equal to x. We're going to go ahead and take our derivative now. On the left side, we have a cosine theta d theta. And on the right side, we're going to have dx. This is perfect because this is exactly what we need. We want the dx there, which you can see that is the value for the dx in our integral. But we still need something to find for the root a squared minus x squared. Well, we kind of have it on the triangle there. You can say that cosine theta is equal to the adjacent root a squared minus x squared over a. In other words, a cosine theta is equal to root a squared minus x squared. And now we have the value for a squared minus x squared, which is what we're going to go ahead and plug into our integral. And so now we have integral of, instead of root a squared minus x squared, we're going to go ahead and write a cosine theta, and now times the value of our dx, which is a cosine theta d theta. And you now can go ahead and combine these things and make it a squared cosine squared theta d theta. We can move the a squared on the outside, so we are left with a simple integral of cosine squared theta d theta. And now, as I mentioned, I'm not going to go ahead and solve this, but what you can use here is a property for the double angle formula. So you can go ahead and substitute this value in for here, and now you can go ahead and integrate using use substitution. I think that will be a great exercise for you. What happens when you have an integral of root x squared minus a squared? That's a little different, right? Notice that now it's the variable that's first and minus the constant. So once again, we're going to go ahead and draw our right triangle. I'm just going to label this for my 90, and let's put the theta on there. And now this one's a little different. Whenever you have the variable first minus that constant, we're going to go ahead and label the hypotenuse x. The adjacent is going to be a. And then once again, I'm just going to show that work using Pythagorean theorem. We have a squared plus some value b squared is equal to x squared. This is so much nicer. It's something that we easily recognize. And so now we have b squared is equal to x squared minus a squared. We can go ahead and take the square root of both sides, and we have b is equal to root x squared minus a squared. Awesome. So now what we found was the value for the opposite side. So we have root x squared minus a squared on our opposite side. The very first thing we got to start is find a relationship between x and a. And in this case, you can see that secant theta is equal to the hypotenuse over the adjacent. In other words, a secant theta is equal to x. Now let's go ahead and take the derivative of this. We get a secant theta tan theta d theta is equal to dx. This is perfect because once again, this value dx is going to be the value for the dx in our integral. So for that, let's go ahead and use tangent theta is equal to the opposite x squared minus a squared over the adjacent over a. We move the a to the other side and we have a tan theta is equal to root x squared minus a squared. This is perfect because now we have the value for the root in our integral. So we can go ahead and start rewriting this. Integral of, now we're going to do a tan theta, the other value, the dx, which is going to be times a secant theta tan theta d theta. So now we can go ahead and multiply the a's together. That becomes a squared. We can put it on the outside. A squared integral of, now we have secant theta tan squared theta d theta. And again, we're not going to solve this, but one thing that I will tell you is we can rewrite the tan theta as secant squared theta minus 1. And when you multiply this, you're going to be left with a squared integral of secant cube theta minus secant theta. Now, this is one that is kind of difficult, but you know, if you're studying calculus, these are two integrals that you should definitely know about. How to integrate secant cube theta and how to integrate secant theta. And maybe that's something that we can talk about in a later video. And now let's continue to the final one. Now we have integral of 1 over x squared plus a squared. This is one that many people recognize and they probably already know the answer to. Once again, let's go ahead and draw our right triangle. We're going to draw our 90 degree, and then let's go ahead and put our theta. All right. So in this particular case, whenever you have x squared plus a squared, there's no root. We're going to go ahead and label our opposite the x, our adjacent the a. And once again, let me just go ahead and show the work here. If we were to do Pythagorean theorem, we have a squared plus x squared is equal to the c squared, which is a hypotenuse. If we take the square root of both sides, we get root a squared plus x squared is equal to c. Okay, so that is going to be the root a squared plus x squared in our hypotenuse. So now let's go ahead and find a relationship between x and a, and that's going to be tangent of theta is equal to the opposite over the adjacent. In other words, a tan theta is equal to x. We can go ahead and take the derivative and get a secant squared theta d theta is equal to dx. That's awesome. Once again, we found the value for dx. That's exactly what we want. And so now let's go ahead and do one final thing where we need to find the value for x squared plus a squared. Well, luckily for us, we have that on the triangle there, and we can go ahead and do secant theta is equal to hypotenuse, root a squared plus x squared, over the adjacent, which is a. Let's move that to the other side. And this is the first time when we actually have to square both sides because the original integral has no root. So we have a squared secant squared theta is equal to a squared plus x squared. So going back to our integral, we have integral of 1 over that value x squared plus a squared. That's a squared secant squared theta times, now we're going to go ahead and draw or write the dx. So a secant squared theta d theta. And this one is actually something that we can solve right away, because one thing you'll notice is that the secant squareds cancel out, which is really nice. The a on top cancels out, and one of the a's in the bottom cancels out, giving us 1 over a integral of just 1 times d theta. And so in this case, this will become 1 over a times theta plus our cheese. Now, I will leave this to you to figure out, okay, well, how do we figure out what the theta is going to be? Once again, this is something that we can talk about in a later video. Hope you enjoyed. Make sure to subscribe, and I'll see you in the next video.